In this video, we're going to do some more questions related to binomial expansions, and we're going to be using Pascal's triangle again for these questions. So we haven't gotten to the formula yet. So 16a says express this term in terms of y. So we are given y is equal to x plus 1 over x, and the only way to get this expression would be to cube this expression. So y cubed would be x plus 1 over x cubed. And we will use the binomial expansion. So the binomial expansion tells us, so if you draw the Pascal's triangle, we have 1, 1 and 1, 1, 2 and 1, 1, 3, 3, 1. This is when n is equal to 3. 1, 4, 6, 4, 1 when n is equal to 4. And 1, 5, 10, 10, 5, 1 when n is equal to 5. So using n is equal to 3, we see that this is going to be x cubed plus 3x squared times 1 over x plus 3x 1 over x squared plus 1 over x cubed. So we have looked at how to do the expansion using the binomial, using Pascal's triangle before. So I'm doing it a bit quickly in this video. So this is going to be x cubed plus, this is going to give us 3x plus this is the second part, is going to give us 3 over x, right? And you can square this and figure out why it would give us 3 over x. And the third term is going to give us 1 over x cubed. So we know that y cubed is equal to x cubed plus 1 over x cubed. This is what we wanted. And we have 3 common here. So we'll factor out a 3. We have 3x plus 1 over x. And we have finally y cubed is equal to x cubed plus 1 over x cubed plus 3, and remember, this was our y. So finally, we can conclude that x cubed plus 1 over x cubed is equal to y cubed minus 3y. So this is what they want us to write. So the desired expression in terms of y is y cubed minus 3y. Now let's do the other part. Let's do part B. So part B just says express x to the power 5. And that is just going to be the, so we just want to find y to the power 5. That is x plus 1 over x to the power 5. So if you do this, now let's try to use the formula. So we're going to start with 5. And we said that k is going to run from 0 up until n. So n is 5 in this case. We start with 0. We start with our first term, highest power. And our second term, 2, 0. And then 5, 1, x to the power 4, 1 over x to the power 1, plus 5, 2, x to the power 3, 1 over x to the power 2, plus 5, 3. So I have given you the formula in the previous video. So we're just using the formula here. 5, 3, x to the power 2, 1 over x to the power 3, plus 5, 4, x to the power 1, 1 over x to the power 4. And finally, 5, 5, 1 over x to the power 5. So now you can punch these in your calculator. So if it's a TI, not a TI, but if it's your FX82, then you have the factorial. You have, so let me just quickly find my calculator first. It's somewhere on my table. But if it, on your scientific calculator, it should be the combinatorics button. So if you look at on mine, I have it on my number 1. So if I press 5 and then shift 1, 0, that should be, so this is, I have to press on my scientific calculator 5 and then I press shift 1. So if you press 5 first and then shift 1, that gives you, shift 1 gives you C. And then you want to press enter your next button. So 5 shift 1 gives you C, 0 is going to give you 1. So this is going to be x to the power 5. And if you repeat, 5C1 is just 5x to the power 4 divided by x plus 5C2 is just 10. It's just the numbers that we have here, right? So 10 x cubed times 1 over x squared plus 5c3 is 10 again. X squared 1 over x cubed. plus 5c4 is just x times 1 over x to the power 4. Finally, 5c5 is just 1 over x to the power 5. So now we have x to the power 5 plus this is 5x cubed plus this is 10x because 3 minus 2 is 1 plus this is 10 over x plus this is 5 over x cubed plus 1 over x to the power 5. So now let's group terms together. We know that y to the power 5 is equal to x5 from this part plus 1 over x5. So this is what we want to find out. Then we have 5x cubed plus 5 over x cubed. I can see that we can operate on this one. And we have 10x plus 10 over x. So y to the power 5 is equal to x to the power 5 plus 1 over x to the power 5 plus, if I factor out a 5 here, I have x cubed plus 1 over x cubed, right? And this is what we calculated for part A. So part A was, I believe, y cubed minus 3y. Y cubed minus 3y. So we can substitute y cubed minus 3y here. And we have 10. If we factor out the 10, we have x plus 1 over x, which is just y. And now we can write y to the power 5 is equal to x5 plus 1 over x to the power 5 plus 5y cubed minus 15y plus 10y. That is minus 5y. So we get minus 15y plus 10y. That is minus 5y. And finally, we have y to the power 5 minus 5y cubed plus 5y is going to be x5 plus 1 over x to the power 5. So that is the answer. Now, from here onwards, let me give you two very important observations. So, first of all, the formula to, instead of using the Pascal's triangle, which, if we have numbers bigger than 5, if your n is very, very big, it's not very convenient to use Pascal's triangle. So what we do is we actually use this formula. So we say that, hey, a plus b to the power n is actually n0 a to the power n b to the power 0, so that is just 1, plus n1 a to the power n minus 1 b to the power 1 plus n2 a to the power n minus 2 b squared plus on and on until we get to nn. A to the power 0, so that is nothing, and b to the power n. So there's one thing I want you to notice here. What is n minus 0? Well, that's just n, and n is on the power of a. N minus 1 is at the power of a. N minus 2, the difference between what we have for our binomial coefficient goes to the power of a. So that is very important. And the number lower at the bottom goes to the power of b, right? 0 is here on the power of b. So that is a very important observation to make. So that is very important. So the formula is very important, but it's also very important to know how the powers of a and b come about. So now that we know that, we can say that, hey, my general term, my r plus 1th term, so why am I saying it's my r plus 1th term? Well, if I want my rth term, so let's say my rth term could be my first term or my second term all the way up until my nth term. So r is just some value. It can be from 1 to n. Then, well, it looks like the binomial coefficient never changes, right? It never changes. And it has to go up until n plus 1. No, r starts from 1 and it goes up until n plus 1. Now why? Whenever we expand a plus b to the power n, then this will have n plus 1 terms. And we can always count that. How do we count it? Well, we can count the lower number, right? Because this 0, 1, 2 is serving as a counter. So we have 1, 2, so we have 1, 2, on and on until n terms here. And then when we add this one, we have n plus 1 terms, right? When we add this term, we get n plus 1 terms. So in total, we have n plus 1 terms. So we can find our first term or all the way up until our n plus 1th term. So TR is going to be, we say, we are selecting from n because our n is the power. And here we have r minus 1. Why? If we want the first term, right, if r is 1, then it's 0 here. If we want the second term, it's 1 here. If we want the third term, it's 2 here. So if you want the rth term, it has to be r minus 1. Now, for a, we are going to raise it to n minus r minus 1, right? We discussed this. The power of a is going to be n subtracted by, and you subtract whatever you have down here. And then for b, we're just going to raise it to the r minus 1th power. So this is what we call the general term of a binomial expansion. And usually people want to avoid using r minus 1. So what we say is we actually express the r plus 1th term. And the r plus 1 term is n r a to the power n minus r b to the power r. So this is the more popular formula, because now you can substitute. So your r doesn't start from 1, but your r starts from 0 and goes up till n. So you can find, if you substitute r0, you get your first term, and if you substitute n, you get your n plus 1 term. So this is just a different restriction on r. So whichever formula you feel, whether it's this one or this one, whichever is more easier, it's up for you to use. So we're going to have to remember this. So these are important formulas, and that's about all the formulas that you actually need to actually understand and do the questions from this chapter. So now, using what we know, let's expand. So we are given expand x squared minus 1 to the power 4. Let's use the idea of binomial expansion. So we start with 4, 0, and we start with x squared, right? We start with a, x squared, and the power is going to be 4 minus 0, that is 4. And the power of minus 1 is going to be 0, that is just 1. So we have 4, 1, x squared will have to be raised to 4 minus 1, 3, minus 1 to the first power, plus 4, 2, x squared will be raised to 2, 4 minus 2 is 2, and minus 1 will be raised to 2, plus 4, 3, x squared will be raised to 1, 4 minus 3 is 1, and minus 1 will be raised to 3. And finally, 4, 4, we have x squared will be raised to 0, which is just 1, and minus 1 will be raised to 4. And now we can solve this. 4c0, actually nc0 is just going to be 1 all the time. If you have 4 objects and you have to select none of them, then there's only one way of selecting none of them. You just don't select anything. So that's just 1. So x to the power 8 plus 4c1, that's just 4, times x, 2 3s is 6. And you have a negative sign because minus 1 to the power 1 is just 1. And if you simplify, 4, 2 is going to give me 6, I believe. So you have 6x to the power 4 minus 1 squared is going to be positive. The next term is going to be negative. So you have 4x squared. And finally, we have plus 1. So that is the expansion for 8a using the formula. You can also use Pascal's triangle. That is still fine. So x to the power 8 minus 4x6 plus 6x4 minus 4x squared plus 1. That is the expansion. And it says, find the coefficient of x6 in the expansion of this thing. So, well, let's just substitute. Because we know what this is, we just expanded this. Let's just say that we know 1 minus 2x squared times, and then we have x to the power 8 minus 4x to the power 6 plus 6x to the power 4 minus 4x squared plus 1. Now, if you look at it, what's the different possibilities of getting x to the power 6? Well, if I multiply 1 by minus 4 to the, with this term, then I get minus 4x to the power 6, right? And that is the only term. The only thing I can multiply 1 with to get something to the power of 6 is this term. And that is it. Now I need to figure out what do I need to multiply minus 2x squared to get something to the power 6. Well, I need to multiply it with this term, right? And what does that do? That gives me minus 6 2 is a 12, x to the power 4 plus 2 is 6. X squared times x4. And that should be the coefficient of x to the power 6. So this should give us negative 16 x to the power 6, and negative 16 must be the coefficient. And it is. So your answer is negative 16. So that is how you do question 8. Now question 9 is also very similar. It just says find the coefficient of x squared. Now let us use the formula that we were talking about, the r plus 1th formula. So tr plus 1 tells us that our term is nr, right? A to the power n minus r, b to the power r, where we have a plus b to the power n. That is the r plus 1th term. So let's use, we know that n is equal to 4. N is equal to 4. We don't know what our r is, right? And then we want to find the coefficient of x squared. So this is important to remember. We have 3x to the power 4 minus r, n is equal to 4. And we have minus 2 over x, right? We have minus 2 over x to the power r. And now let's simplify this. We have 4 over r. We can write this as 3 to the power 4 minus r times x to the power 4 minus r, right? Because you know that the power rule tells us that a times b to the power n is a to the power n times b to the power n. So using that rule, we get this. And then we can say that, hey, whatever we have inside your bracket, we have minus 1 to the power r, 2 to the power r, right? So we take out the negative 1 and we'll raise it to r. And we have 2 to the power r here, and we have x to the power r. So I want to club all of my constant terms and the variable terms together. So we have 4r, that is going to be a constant, 3 times 4 minus r times negative 1 to the power r, and I have 2 to the power r. So that is all my constant terms from here. And my variable terms is x 4 minus r divided by xr. So if you simplify this, you'll get x 4 minus 2r. And now that we have this, we can say, hey, x 4 minus 2r has to equal to x squared, because we're looking for the coefficient of x squared. So therefore, 4 minus 2r is going to be equal to 2. So 4 minus 2 is 2r, and r is equal to 1. So now we want to substitute r here. So coefficient is going to be 4, 1, right? 3 to the power 4 minus 1 is 3, minus 1 to the power 1, 2 to the power 1. So now we have 4c1 is just 4 times 3 cubed is 27 times 2 times negative 1. And that gives us negative 216. That is your coefficient. And you can also use Pascal's triangle to solve for this one. So that is your answer. Question 10, you can do it exactly in the same way. Find the term independent of x in the expansion. So you use our general formula again. The r plus 1th term, or you can use the rth term, depending on how you bound your r, is given by nr. I prefer using this. A to the power n minus r, b to the power r. So what is our r? N is 4. We don't know r, a to the power. So what is our a? A is x squared. We have x squared, we have 4 minus r. And then we have minus 3 over x squared to the power r. So the second term, b to the power r. Now let's simplify this. 4 over r, x to the power 8 minus 2r, right? Because we can multiply these two. 4 2 is 8 minus 2r. And now we have minus 1 to the power r times 3 raised to the power r divided by x to the power 2r. So what do you do here? You take minus 1, you take whatever you have inside the bracket as minus 1 times 3 over x squared. And then you're raising the whole thing to r. So that is equal to minus 1 individually to the power r. And then you have 3 over x squared to the power r. And 3 over x squared to the power r is 3 to the power r divided by x squared to the power r, which is x to the power 2r. So you know that a over b to the power n is going to be a to the power n divided by b to the power n. So that is what we are using. So we have 4r x to the power 8 minus 2r divided by x to the power 2r. And then we have 3 to the power r and minus 1 to the power r. And we get 4 and r, x to the power 8 minus 4r, 8 minus 4r, and 3 to the power r and minus 1 to the power r. Now it says that the term independent of x, so we don't want any x. And for that to happen, 8 minus 4r has to be equal to x to the power 0. This is just 1, right? We want the term independent without involving x. So we solve for 8 minus 4r is equal to 0. And when you solve this, r is equal to 2. And to find the term, that is just going to be, because this whole thing is going to be 1, then your constant term is just going to be 4, 2, 3 to the power 2 minus 1 to the power 2. And solving this gives us, this is 6 times 9, that is 54. So that is your constant term. So question 14 is basically what we have been doing. So you just use Pascal's triangle to expand, and then you choose x is equal to 10 and y is equal to 1 over 4. And then you substitute whatever expansion you got, you substitute these values to estimate this. So that is why I'm not going to be doing 14. So question 12. Now question 12 is the type of question that Cambridge really likes asking. These are very popular questions. So it says that the coefficient in the expansion of this. So let's look at, first of all, the expansion of 1 plus ax to the power 4, right? The general term is given by 4r, 1 to the power 4 minus r, that is just going to be 1, right? So we don't really care. And we have ax to the power r, because ax is the second term. So this simplifies to 4 by r, a to the power r, x to the power r. And it says the coefficient of x squared. So let's say that r is equal to 2, because that's how you get x squared here. So therefore, we have the coefficient is given by 4, 2, a to the power 2. And 4 choose 2 is 6a squared. Now let's look at the second thing. Is 30 times the coefficient of x in the expansion of this. So we are given another expansion, and that is the expansion of 1 plus ax over 3 to the power 3. So we can find the general term again. R is given by nr, so n is 3 here. 1 to the power 3 minus r, that is just 1, so we don't really care. And we have ax over 3 to the power r. So we have 3 over r, a to the power r, x to the power r divided by 3 to the power r. And now we want to set x to the power r to be equal to 1, because it says 30 times the coefficient of x. So we just want x to the power 1. So now we have, this gives the coefficient to be 3, 1, a to the power 1 divided by 3. And 3, choose 1 is just 3. So you just have a to the power 1. So now we are given the coefficient of x squared is 30 times the coefficient of x. So this 6a squared is equal to 30 times the coefficient of x in the other expansion. So 30 times a. And we want to solve this. So if I divide by 6 on both sides, I have a squared is equal to 5a. A squared minus 5a is equal to 0. A minus 5 is equal to 0. And let's think. Can a be negative? Well, no. Can a be 0? Right? If a were to be 0, this would be 0, and 1 to the power 4 would be just 1. So 30 times 1, this would just be 30. And this would be 0, right? This would be 0 again, and 1 times cube is just 1. And this 1 is not equal to 30 times 1, right? Those things are not equal. So a cannot be 0. So that is why you only want to choose from this a is equal to 5. That is the only, if it's a equal to 0, it does not work. So that is the answer. A should be equal to 5. No, it says find the power of x that has the greatest coefficient in the expansion of this. This one, I would recommend you to just expand it out to the power 4. So that is going to be, if you remember Pascal's triangle, you would get 3x to the power 4 plus 4, 3x4 to the power 3, 1 over x plus 6, 3x4 to the power 2, 1 over x squared, plus 4, 3x squared, 1 over x cubed, plus 1 over x 4. So now if I simplify this, I get 81x to the power 4 plus, and you can just solve for everything. So that is 3 cubed is 27. 27 times 4 is 108. You have x to the power 4 3s is 12 by, so we have x to the power 12 by x. So that is x to the power 11 plus 3 squared is 9. 9 6 is 54. You have x to the power 4 2 is 8. 8 minus 2 is going to give me x to the power 6. And we have here 4 3s is 12, x squared by x cubed. So that is 12 over x. And finally, we have 1 over x to the power 4. So which power of x has the highest coefficient? Well, it's going to be x to the power 11. That is what has the highest coefficient. And finally, let's do question 15. So given that the expansion of this is equal to this, find the value of p and q. So let's go ahead. You have x squared plus 1 over x to the power 4. Let's just expand this. Using Pascal's triangle or using the formula, you will see that this is just... Now, another way to write 4, 0 is to write 4, choose 0. So that is just another notation. X squared 4. Then we go to 4c1. We just change the lower number. X squared 3, 1 over x plus 4c2. X squared squared, 1 over x squared plus 4c3, x squared, 1 over x cubed. Finally, we have 4c4 and 1 over x to the power 4. So let's clean this up a little. We'll get 4c0 is 1. And we have x to the power 4, 2 is 8. Plus 4c1 is 4 times, this is going to be x to the power 6 divided by x is going to give me x to the power 5. 4c2 is going to give me 6. I have 6, I have x to the power 4 divided by x squared. So that is 6x squared. And here I have 4 again. 4c3 is 4. X squared times 1 over x cubed. And that is going to give me 4 over x. And finally, this is just going to give me 1 over x to the power 4. 1 over x to the power 4. So now we have this. We can easily figure out what this is going to be. X squared minus 1 over x to the power 4 is going to be wherever we have an odd power of x, like these two, right? This had an odd power and this had an odd power. So wherever we have an odd power of 1 over x, those are going to be negative. So we have x to the power 8, we're going to be minus, and we discussed why it would be negative in the previous video, plus 6x squared. This is going to be negative, plus 1 over x4. And we are asked to subtract, right? So I'm performing this thing, subtract this thing. So 8x to the power 8 minus x to the power 8. These are going to cancel out. 4x to the power 5 plus 4x to the power 5. That is 8x to the power 5. And these terms cancel out. We have 4 over x. So 4 over x minus of minus 4 over x. That is 8 over x. And these terms are going to cancel out. So that is what we get. So your P is equal to Q is equal to 8. That should be your answer. And without using a calculator, find the exact value of this. Well, this is exactly what we just did. Now we just need to substitute x is equal to root 2 if you look at it carefully. So we have 8 root 2 to the power 5 plus 8 divided by root 2. So what is root 2 to the power 5? Well, that is 8 times 4 root 2, right? Root 2, 4 times root 2. That is root 2 to the power 5, because this is 1 and they're going to add up. Root 2 to the power 4, that is 2 squared. And 2 squared is just 4. So 8 fours is 32 root 2 plus 8 times root 2 over root 2, root 2 over 2. I'm going to rationalize this. I multiply and I divide by root 2. So root 2 times root 2, I just get 2. And then 8 divided by 2 is 4 root 2. That gives me 36 root 2. And that is your answer for B. And we're done with this topic. So we'll move on. There are some more questions that we can do using the formulae that we are given. And that is about it. And there's one last idea that I want to give you. And that is nk is equal to n minus k. So basically what I'm saying is 5c3 is equal to 5c2. It's going to be the same thing. And that is why you are seeing the symmetry in Pascal's triangle. You see 1 and 1. 2, 1, right? You see 1, 3, 3, 1. See? 3, 3, 1, 1, 1, 1. 1, 4, 6, 4, 1, 4, 4. So this is why these things match up, because of this formula. And one way to understand this is in mathematics, in combinatorics. Maybe not in real life, but being chosen is the same as not being chosen. So for example, if I have 5 objects, I want to select 3 of them, well, I automatically have 2 of them on the side 2. So selecting 3 is the same as selecting 2. If I have n objects, selecting k of them is just the same thing as me selecting n minus k of them. So that is a formula that you may want to remember. N choose k is equal to n choose n minus k. So for example, you can say, well, hey, 5, 0 is going to be equal to 5, 5, right? And that is the ends. That is the ends. Those are always the ends of the Pascal triangle. It's the situation nk and n minus. The ends are always this situation, n0 and nn. That is why they are equal by this formula. So it's choosing k objects, and if you choose k objects, you automatically have a separate pile where you have chosen n minus k objects. So that is the last idea. And that is it for this video. Thank you, and we'll move on to the next topic, which is still more binomial expansions. But now we have all the formulas and all the tools that we need to complete this topic.